introduction. I am Saguchi from Bridgestone. So within Bridgestone, I am in the development of the digital engineering. So today, as for the tire industry and also the environment which Bridgestone is standing at, and especially as Dr. Ito mentioned, the material development. How or what kind of expectation do we have toward the quantum computing for the material development? So first of all, let me share this. I'm sure that you all know, especially in terms of the environment, we are all facing this issue. It's getting more serious. CO2 is one, and global average temperature is another, and also sea level is rising. So as you know, each country targeting 2050 is going to be carbon neutral. So that's the targets which we are moving toward. As tire industry, of course, we have to achieve, or we have to help or contribute to achieve the targets. On the other hand, into the future, we also have to think about the population increase. So to 7.84 billion is the number of the population in 2020, and toward 2050, 9 billion people are expected. And of course, accordingly, the mobility is going to increase. Maybe in terms of the number, it will be double. That's one of the calculation or simulation. So we are a tire company, but the cars which you have, of course, have tires. So as the number of the vehicles increase, the number of the tires are going to increase. However, of course, we have to think about the environmental aspect, and how we are going to make this happen is something which we are always thinking about. So changing the gear a little bit. Well, this is the market size of the tire industry. And yes, I think you see the one in the orange, the circle, that's the automobiles. And the y-axis is a global economic size, and also on the x-axis is a global market share of Japanese companies. And yes, automotive industry, yes, it's huge in terms of the global market size, and also Japan is deeply engaged in the industry of automotive. When it comes to the tires, well, it's about 30 trillion yen its size at the global level. So the big orange circle, maybe just right below the big orange circle, is where tire industry is standing at. And also Japan is accounting for about 25% of the entire global market share. So I think Japanese companies of the tire industry is also involved deeply in this industry. So what are we thinking about as a tire manufacturer? Well, yes, a tire is black and round, and I'm sure that you know that it's using rubbers. And rubbers, what's inside of those rubbers? As natural materials, natural rubber is also used, or sometimes synthetic rubber is used, which is derived from the oil. And also there is a carbon inside, and this is also petroleum derived. So maybe half of the tire composition is going to be depleted because it's using oil. So the rubbers are used in tires. And into the future, when the economy is going to develop more, we have more people, and mobility is going to be enhanced, what do we do in using rubber? It's a big, big question which we have to solve. So let me talk about the Bridgestone. So as Bridgestone, when tires are going to increase in number or volume, and also we need to keep the sustainability, how do we address this issue? On the right-hand side, the pink circle. This is, well, the tire is used in the then it will be converted into the energy by going through the incineration, or heat treatment. But now we are thinking about recycling those tires, or maybe the rubbers are going to be classed and then going to be recycled to the rubbers, and that is described in the central green circle, so around here. And also, rubbers can even be converted back to their raw materials so that it can be repurposed for the other elements. So that's another thing which we are looking at. And also the new natural resources also can be considered to be used for the tires. So again, we need to think about diversification of the materials, because otherwise tires will not be sustainable. So under the circumstance, well, toward 2050, we need to really think about 100% sustainable materials so that we can also achieve or enable carbon neutrality. Well, this is the target which Bridgestone is looking at. The left-hand side bar is where we are standing at now. So as I said, more than 50% of the tire material is derived from the petroleum. So we need to convert it to the natural resources or maybe recycled materials. And even we are currently using those recycled materials, but it's not that much. We need to really increase the ratio. And then when we have more recycled materials, then it will also have more emission. So how we can diversify the raw materials so that it can be more sustainable. At the end of the day, toward 2050, all of the materials can be either recycled or maybe natural resources. Unless we replace with those new options, we will not be responsible for the earth. So going to change the topic, I'm sure that you drive and you feel the same way, but tires are derived from petroleum, but tires carry life. So we have to make sure that you can enjoy the mobility life with safety and security. So safety is the utmost important priority for us. At the same time, we need to utilize the diversified, sustainable resources. So that's a huge question which we need to get answered. So under this circumstance, we are developing the materials, and a little bit hard to see, but this is a history. The vertical axis is the environmental performance and also how we make sure it's safe. So we try to use the material which is less breakable, and also how we can be more efficiently developing those materials. And yes, left-hand side is, yes, we are kind of measuring what we see. And also at certain time, we do the material simulation so that we see these materials can be optimal or suitable for tire development. And then using the simulation, we try to come up with several options of those replaceable materials. However, sorry, this is a little bit shabby images, but left-hand side is rubbers used for the tires. And this actually is quite complicated or complex material. So let's say the atom is connected, trying to produce a polymer, and then it is branching, or maybe it's kind of entangling. Well, so as you see, just like pasta. So pasta, you know how long one pasta is and how it is entangling together. And also sometimes the pastas are connected or glued, or maybe cheese can be mixed, or maybe olives can be mixed. So on this dish, this is pasta and trying to extend the pasta to maybe double or triple. We want to understand how this is going to behave at the micro level. Controlling that is one part, but at the same time, we need to also use the sustainable new material so that it can be better. And then you have to observe. That's another aspect which we need to do. But when we need to do, to see something invisible, we have to do the material simulation, and we want to leverage material simulation. But as of today, this is a left-hand side picture. Maybe at certain point we can actually solve at the atom level. But at the end of the day, we need to really kind of curve out some of those pasta which is on the right-hand side. So a part of the pasta is being simulated now. So we just have a part of the simulation and then trying to really think about how the entire pasta as a dish is going to behave. And that's something which we need to know. So at the end of the day, we need to simulate the entire pasta and then understand the behavior, not just a part of the pasta dish. And then maybe seasoning or material, or maybe the thickness of the pasta can be changed. Maybe 2 different types of the pasta can be mixed. So maybe sometimes it can be connected chemically. When we extend them, then how we can actually extend, how much we can extend. So we are willing to understand these questions. However, as I mentioned, as of now or today, things which are possible now is just a part of the materials simulation, not the entire pasta. So again, well, maybe the we are talking about nanoscale, but we need to be able to predict the materials at that nano or micro level. So this is our expectation toward quantum computers. And as Dr. Ito mentioned, the material simulation will enable maybe the molecule or maybe the atom is going to be understood at the polymer level, and also maybe it's kind of connected at a certain complexity. And because of the complexity, it's really hard to understand the rubbers. And because of that good analysis, we are able to make sure it's safe to use the rubber materials for the mobility. So again, at the beginning, as I mentioned, yes, to really enable the sustainability with the tires, we also want to make sure it is safe and secure. So once again, we want the quantum computer to understand or to solve the behavioral problems of the entire pasta. So that's how we want to make sure it's safe and secure and also sustainable for the future environment. And that's where we have a huge expectation toward quantum computers. So lastly, as Bridgestone, we are looking into the future of 2050. And yes, we want to really see this sustainable mobility with safety and security, so that we want to offer or contribute to the environment for the future children. So how we are going to leverage sustainable materials to really offer the safe and secure components for the mobilities. To really enable the society, we want to fully leverage the quantum computers for material simulation, and also as a structure of tire or maybe structural FEM. So these are not just what we want, but it can be even more. in the quantum computing. So that's all from my side. Thank you very much. Thank you very much for your kind attention. Thank you.